All right, welcome back from lunch. I hope you had a nice break. And I also hope you're enjoying your time here today at our very first INTERSECT at CMU conference. So I'm Lori Weingart, for those of you who don't know me. I'm the provost at Carnegie Mellon University. And really, it's a special honor for me to be here with you as we continue to celebrate the opening of the Tepper Quad. I mean, what about this building, huh? It's incredible, but also what it's activated. I don't know if you've been walking around today and just watching the students interact on kind of a more typical day. It's pretty impressive. Before I started my role as provost, I served as a senior associate dean at the Tepper School of Business. In fact, I spent my whole teaching and research career here at Carnegie Mellon. So I personally feel a very special connection to this new Tepper building because I spent the majority of my career doing research on interdisciplinary teams, teaching students how to negotiate, how to collaborate, how to manage conflict in service of innovation, and which is really a central hallmark to Carnegie Mellon and to Tepper's culture. And certainly that's what we're striving to achieve in this building. As provost, I can tell you that at Tepper, as well as in all of our colleges, you'll find unlimited opportunities when it comes to collaboration. Our students, our faculty, our researchers, we all work across disciplines to produce work that makes an impact, work that changes the way we think and shapes our society. It's really part of the DNA here. It's what attracted me to the university and actually strongly influenced my research. And that's what makes this next panel so intriguing. Designing intelligence, shaping AI and society. It's a perfect conversation for Carnegie Mellon to host during this INTERSECT at CMU conference. So considering the emerging possibilities in artificial intelligence, top leaders and researchers in engineering, business and public policy come together to form a shared vision of a common future for us all. It's at this intersection where truly amazing ideas come to life, and that's exactly what we strive to achieve here at Carnegie Mellon. So to kick things off, please join me in welcoming Andrew Moore, a distinguished computer scientist, of course, with expertise in machine learning and robotics, and the dean of our School of Computer Science. Dean Moore.
I am delighted and honored to be able to introduce your moderator for this panel. The reason it's such a delight and honor is that School of Computer Science and Tepper College really, really need each other. We, at the moment, are both awesome institutions. Tepper College has absolutely grown in every respect over the last decade. I've been so delighted by that. And here's why I particularly like Tepper. It's because it is a proper set of honest, geeky, nerdy faculty. In other words, thank you. I love the fact that I travel in government and industry circles, and there's so many think tanks and panels where you get a bunch of business folks pontificating on things like AI without any understanding of it beyond what they saw in Terminator and Her. Whereas here, faculty who are good friends of mine, like Mike Trick, who was here yesterday. Oh, still here. Okay, you're such a nerd. My God. Right. This is someone who has single-handedly written optimization software for baseball game scheduling for the last 20 years at a level beyond anywhere else. That is the kind of business partner I want. And the School of Computer Science, by the way, is also awesome. We are top in terms of the most desired graduates. We are really proud of the gender diversity and commitment to gender equity in the college. We have become the place which has the most selective incoming classes of anywhere, including the Ivy Leagues. And it's the 250 faculty who do amazing things all the time, which really impress me. So here's the picture I need you to have in your heads from this comment. School of Computer Science and the Tepper College really need each other. And working with Bob Damon, he and I are often fighting back to back against the rest of the world. We together, and I really want to make this clear, together, that combination of actual mathematically sophisticated business management and ridiculously advanced technology is much stronger than either of those things separately. So the thing I want you to remember from this is me and Bob standing back to back on a rock somewhere, surrounded by people from MIT and Stanford and Penn, trying to dislodge Carnegie Mellon. We got our swords out. That's the relationship that's going on between the colleges right now. One of the places it's best exemplified is the Masters in Product Management, which we've created together, which is so exciting for all of us. I was for a while in industry, and it was product managers were the only thing in the world harder to hire than School of Computer Science software engineers. So the fact that we're doing this together makes me really excited. Another reason SCS is awesome, just do the math. 3/4 of your panelists today are from the School of Computer Science. The panel is going to be moderated by Laurence Ales, who I have really great respect for as a perfect example of this sort of approach in Tepper. Laurence has analyzed incentives from an economics point of view, right from the level of tax incentives through to how you best actually incentivize entrepreneurialism in society. I actually looked at some of his work prior to this, and I love the fact that it's not based on rhetoric or anything like that. It is based on proper mathematical analysis. So really excited to see what this panel is going to do under Laurence's leadership. And let me now introduce Laurence Ales. Thank you.
Well, thank you, Andrew, for that nice introduction. And good afternoon, and welcome to our second panel of the day. What I want to do today is have a bit of a chat, a bit of a conversation on how computers learn, how computers make decisions, and what does it mean for all of society. I'm joined here today with leaders and scholars in the field, and I want to go right away and introduce them. Next to me, I have Alexander Gray. Alexander has an interesting career touching different aspects of AI. He is currently head of AI science, basic research at IBM. Prior to IBM, he was a professor of machine learning at Georgia Tech. He then went on to co-found and eventually be a CEO of a startup, Sky3, big data machine learning acquired in 2017. So, next, we have Henny Admoni. Henny is an assistant professor in the Robotics Institute here at CMU. She leads the Human Robot Partners Lab. Henny studies how to develop intelligent robots that can assist and collaborate with humans on complex tasks. You might have heard her also on radio. She's a popular, common contributor on radio and other media. So welcome, Henny. We then welcome Justine Cassell. Justine is Associate Dean for Technology, Strategy, and Impact in the School of Computer Science. She's also a professor in the Language Technology Institute. She's a co-director of CMU's Simon Initiative and co-chair of the Global Future Council on the Future of Computing at the World Economic Forum. Welcome, Justine.
Thank you.
All the way to the end, we have Param Vir Singh. He's a Carnegie Bosch Associate Professor of Business Technologies and Director of the PNC Center for Financial Services here at the Tepper School of Business. He is the recipient of the Information Society Sunday Slaughter Early Career Award, and his interests are focused on the digital economy, analysis of user-generated data. So welcome, Param.
Thank you.
So I'm very excited to be having this panel. When I was asked, some of my first thought was how is the right place and the right time to be having this conversation. Why is the right place? I want to do a short history lesson. I want to go back to the 1950s. And at that time, the building looked really different, and the school was GSA at the time. And there we have a figure like Herb Simon, who I was passionate about thinking about how human learns, how human process information, and how humans act. Now, that interest came together with another interest he had, which was on, at that time, early computers. So this interaction, and this is a collaboration with Alan Newell, became what was known one of the first AI computer program, the logic theorist. Not as fancy as some of the AI product we have now, was actually pretty geeky and dorky. He would try to do very simple logic proofs. But that idea that we need to understand how humans learn to write AI products is something that I'm sure we will also touch on today. It's alive and well. And I will go even forward. At that time, the limit was how data is available and computing capacity. But even at that time, Herb Simon had the insight that we should go about teaching computers not trying to explain the structure of the problem or trying to put some frame on it, but was really thinking about a more data-driven approach to learning. How we should, and I might quote him verbatim here, how we should allow a computer to bump into things, how we should allow a computer to get hurt, and to go from there. So again, that seems to be at the core of some ideas of machine learning and deep learning that we're going to touch at some stage. Now, I should be clear. I'm not a computer scientist. I'm the remaining quarter, as Andrew would say, of the panel. I'm an economist. So for me, when I think about AI, I have a kind of a different perspective. I start thinking about what does it mean for society? As an economist, I start thinking about, well, have we seen anything of this magnitude before? And the answer is kind of. AI is up there to some of these transformative technological changes that we've witnessed a few times. To put things concretely, I would like you to think about electrification as an analog. Okay, so this is a technology that is not going to be an improvement, a marginal improvement in our day-to-day life. It's going to be completely transformative. We talked in the first panel on how it's going to, or is appearing in our homes, in our cities. It's going to be a technology that is not only minor changes to business practices, it's going to have all new industry appearing and disappearing. So that leads me to why is it a good time to have this discussion now? Because with these big changes, we'll have inevitably winners and losers. So it's now the right time for a business leader to think about what should he do about this upcoming technology, and for a policymaker, how should he react to this upcoming technological change. Okay, I'm going to stop. I want to let my panelists, I want to let the expert talk about this. And before we go there, I just want to remind you that if you're in the audience or if you're following us on Poets and Quants or our social media platform, you can submit questions on slido.com, prompting code hashtag A954. That is hashtag A954. Okay. I want to let you talk about your exciting research. I'm going to give you a few minutes to talk about that, and then we can open it up. So I want to start with Alexander. As I said, you've touched very different aspects of AI in your career. Why don't you tell us some about this? What are you currently working on? What are some of the exciting projects at IBM?
First, I want to say it's great to be here, and I'm a CMU alum, and in fact, this guy right here in the pink shirt was my advisor. So I can tell you, having been in many places, this is the best place on earth. So the kinds of things that I think about, so IBM research is very, it's been around for a while, and longer than most tech companies have been around. It's very large, 12 global labs, 3,000 researchers. So a big chunk of that is AI. So it's both fundamental research, much more so than you might expect companies to do. We're kind of quasi-academic, actually, in that sense. Probably the biggest thing there, to me, one of the most important things that we work on there is, you could argue this, the central open problem of AI, at least I argue it is, which is the two big paradigms of machine learning, which is sort of in full swing right now, and then the classical AI paradigm, or symbolic AI. They have complementary strengths. And so when we talk about real foundational stuff, to me, I always come back to that. There are things machine learning cannot do. There are things, of course, classical AI could not do. And they are actually somewhat complementary. So, so that's a big interest and activity of mine. And the other, of course, is the relationship to business. And IBM arguably is the biggest of the B2B AI companies. We hear a lot about the B2C companies. The research problems and activities are somewhat different. There's a lot of overlap, but in the business world, meaning, because when I say B2B, IBM, as you may know, a lot of its business is actually some of its products, some of its consulting. Consulting, means IBM may actually live inside other companies, sort of like a organism hosted in another organism. So we really know what happens in these companies and what their needs are and so on. So, and they're a little different than maybe the mainstream that we hear a lot about. So there's big data. That was my research area that I did for a long time. Of course, still important, but it turns out small data is a big need, because not everyone has 10 million labeled examples of whatever thing they're trying to predict. So, in fact, arguably the more critical the problem, and IBM is the kind of company you go to when you're a bank and you need a machine that runs something really critical, like bank transactions and so on. When you're inside those really critical problems, then you don't necessarily have a lot of examples of insurance fraud and so on, or at least specific kinds of insurance fraud. You may have 10 examples. So that's one. Another one is domain knowledge. So what are these companies that are not fancy tech companies, what are their crown jewels? Often it's domain knowledge. It's the fact that they deeply understand insurance or manufacturing or something. That knowledge is something they want to really combine with data, which we talk a lot about. It's the basis for more or less what we call AI. It's mostly machine learning today. But there's knowledge, and we still haven't really, that's kind of an open problem in a sense still. And then the third, I would say, is trust. That's not something we think enough about. When you really are running some critical part of your business, and all parts of business, all the critical and the non-critical parts, I do believe AI will impinge on all of them. And there are many barriers to that. Trust. So one is trust in the actual deployment and so on being smooth. It's actually not very smooth today. Another aspect is understanding if you're really going to have a machine diagnose you and prescribe your drugs and all this stuff. Someone has to be able to understand it. So the explainability is really key, but that's true of even things that are not life or death. Maybe $100 million depends on it, but no one's going to die still. That we need to have explainability. And that a lot of how trust becomes sort of instantly an AI ethics. Not everyone. It's not at the top of everyone's list, let's just say, in industry, right? Top is, hey, I got to make my Q3 numbers. But the reason it actually starts to rise to the top of the list, despite that, is regulation. And I believe regulation is a kind of forced form, but of having to pay attention to ethics. But many industries today are regulated, but in terms of how they use predictive models, or some. I predict it will be all industries that where they're doing something that affects. The reason we regulate is when something clearly affects society. But there are many things like that, and AI will touch all of those things, and many of them are not regulated yet. It's companies' responsibility, I believe, to build in all the safeguards that people want or should have before. We shouldn't wait for the hammer to come down from outside. We should be responsible and think about these things. But technology is not there. So these are the some of the areas that really come to the fore in B2B driven AI.
Thank you for those comments. You touched on a couple of points. We're going to go back to them later on. But now I want to hear about Henny. I like working in Newell Simon. There is a lot of activity that I peek into those robotic labs, and I think that you're responsible for some of them. Why don't you tell us about your research a little bit?
Absolutely. Thank you. And I'm delighted to be here. So thank you all for being here and for watching. So I'm a professor in the Robotics Institute, which is just across the way. And my dream is really to build robots that make people's lives better. And that involves making the robots intelligent and making them responsive and making them adaptable to the humans that they're working around. So one of the domains that's most exciting to me is assistive care, is robots for people, for example, with motor impairments, where a robot arm on your wheelchair could allow you to pick up a glass of water and take a drink, right? Interact with the world in ways that you can't necessarily do without technology. So technology has a tremendous capacity to improve people's lives. And this robot arm is not a dream. This is actually, there's a commercial product from a company called Canova Robotics in Canada that you can buy. And it's a robot arm that you attach to a powered wheelchair. And people use it to perform activities of daily living. The challenge, if you've ever played a claw machine at a carnival, is that controlling this kind of robot, this very sophisticated arm with a limited device that you use to drive a wheelchair is really hard. And actually the paradox is that the less physical capability you have, the more you need the robot. But the more you need the robot, the less capability you have to control it. So that's where AI comes in. And we use artificial intelligence to make these robots predictive, to actually have them adapt to their human user, to predict what the user is trying to do, and then to take action to complete that. And we've shown, collaborators and I have shown, that robots that take human activity into account and try to predict the next action can actually lead to much less effort in using these systems and can help you complete your tasks, like picking up a bite of food, much faster. So some of the signals that we use are human behavior signals, right? We as humans understand each other's behaviors a lot. We understand eye gaze, we understand gesture, we understand nodding. I see people nodding. My goal is to make robots understand those kinds of behaviors so that they can become these kinds of seamless collaborators with people. And this isn't just for robots for people who are motor impaired. This applies to robots throughout the world. In everyday life. I have visions of robots helping older adults age in place at home, maybe take care of some of the more rote tasks at home, like laundry or cooking, so that older adults can live in place and not have to go into assisted care. Or better yet, make it so that caretakers who are helping taking care of older adults don't have to do those rote tasks, don't have to do the transferring and the toileting and the cooking, and can instead spend time socializing with the people they're there, right, to take care of, right? To do the thing that humans are actually good at. So that's the vision. I think the critical part of my work is that I combine the robotics with an understanding of people, with cognitive science and cognitive psychology in particular. I think it's very easy for robotics to treat people as an afterthought, right? Robots are operating in human environments, but it's sometimes easy to treat humans as an obstacle to be avoided or a piece of cargo to transport and not consider the signals and the richness of the human part of that equation. And so if you remember nothing else from what I say today, I hope you remember that the way, in my mind, to push AI forward is to combine the mathematical models that we have with our understanding of human psychology to treat it as a coherent human-robot system together. And so the kinds of research that I do is truly interdisciplinary. We talk about interdisciplinarity a lot, but Carnegie Mellon is a place that really does value that. And so a lot of what I think about is both how do we model humans and how do we build better robots.
Thank you, Henny. Justine, as I understand, like you also are interested in interaction between human and machines. Emphasis is a bit different. Like you're, it seems like a central theme of your research is the conversation between people and between people and machine, and bringing a machine up to being a good conversationalist, I take it. Do you want to tell us more about what you're working on?
Perhaps the largest umbrella term for what I work on is social AI. And actually, I want to dispel a myth or maybe answer a question. And I was asked the same question on a famous syndicated national NPR show, which is whether I do this work because I'm a girl and girls are more social. I'll give you roughly the same answer I gave the interviewer, which is that to be a senior woman and to move forward despite being told you're pushy, noisy, and difficult, you can make it over any obstacle. And so you're more likely to come up with innovation. So now that we've dispelled that, let's go back to social AI. So it turns out when you look at people working, and I'm very interested in the business context, that people's work, that is their task performance, what they're paid for, depends intrinsically on their social skills. And in fact, work by the former provost Mark Camlett and his colleague Seth Goldstein has shown that the jobs that are going to diminish with the AI revolution are jobs that don't demand social interaction. And the jobs that are growing and are going to continue to grow are those jobs that require good social skills. So I ask two questions. What are social skills? How do we preserve them in human-human interaction mediated by computers and in human-computer interaction? How do we save those things that in fact make us most human, that humans are good at? And I do that by studying these work contexts in which people communicate. And I look at data that most people throw away. That is, hey, how'd your weekend go? What'd you do? And it turns out that if you're a good communicator, if you can link a bond, build rapport with your work collaborator, your performance on your work will be better. Both people's performance on their work will be better if they have an infrastructure of social interaction. So I model these behaviors in the same way Henny does, and I also use many of the techniques that Alex talked about. I kind of felt like I was playing that game of I'm going to grandmother's house and I'm bringing explainable AI, small data, human modeling, and I'm going to add social interaction. So what we do is we watch human-human interaction. We analyze it at 1/30th of a second. We videotape everything. We analyze every eyebrow raise, every head nod, every gaze shift, every movement of the hands. You can see why I study this. Every movement of the torso. And then we translate that into a model of how human social interaction, moment by moment, improves task performance. And then that is turned into algorithms that are put into sometimes a robot and sometimes what's called a virtual human. That is a 3D animated agent that interacts with people. And then we evaluate its ability to improve task performance with our machine collaborators. So that's kind of the rough story.
Thank you. I want to move to Param. You're a professor here in the business school, so you naturally think about more between the frontier of business and AI. Can you tell us a bit about what you're working on?
Yep. Thank you, Laurence, and I'm really delighted to be here, and not to make people jealous. I have an office in this building. I really love it, with a nice view looking over the Central Catholic. Get to see their their football practice. Just one. So actually, I'm almost really intrigued by what the other panelists do, and actually, this is where like a lot of my interest in AI has emerged from the time where you see, like at CMU, you get exposed to what is possible with robotics. And then the media takes this issue and says, people like me and Laurence may not have a job, will be replaced by a robot in the next 5 years and so on. And that's where I got interested in looking at AI. And I look at from a perspective of economic incentives in this system and how this is going to influence business as well as society. And a lot of my work is, I would say one stream looks at like building AI solutions for business problems. Another stream looks at if the business were to implement the solution, how is it going to influence society? And rather than telling more about other streams of this, let me give you 2 examples where which were like really good applications of AI, but could have a bad impact on society. Right, so the example, there is a study that one of my students did was working with Airbnb. I think if you are visiting from outside, some of you guys may be staying on Airbnb, or at least maybe some of you guys are hosts at Airbnb. Now, at Airbnb, if you're a host, one of the things you would see is pricing the property is very hard. Now, at Tepper School, we teach you how to price your property, how to dynamically optimize, but for an average host, it's going to be really hard. And what was happening is neighborhoods, hosts which were in neighborhoods which were really wealthy, they were pricing it really well, but the poorer neighborhoods were pricing their properties really poorly. And this is a real situation where you can build an AI solution to help the host price their property very well. And this is exactly what Airbnb does. They call it a smart pricing algorithm. Offer it for free to all the hosts. And if a host from a poor neighborhood was to adopt this, you would see he would get much higher returns compared to what he was getting now. And even in the wealthier neighborhood, they could benefit from adopting it. So you would think this kind of AI technology is going to level the playing field. But eventually what ended up happening is that the poorer neighborhoods did not adopt this algorithm at all. Richer neighborhoods adopted this. They started doing even better. And the poorer neighborhoods ended up doing even more poorly compared to before. Instead of bridging this divide, it ended up expanding the divide. And these kind of situations are where some places we are looking at and trying to figure out what could be done in these scenarios. Let me give another example. This is in Boston City. If there is somebody from Boston, they would acknowledge there was Boston City thought, okay, we want to use AI to improve the governance of the city and allocate resources in the city properly. And one of the things they did was, this was very nice technology. They used something called a street bump. This was an app. It's a smartphone app. You put it in, you basically get this app on your smartphone, and when you are driving, if on the roads your car hits a bump, your smartphone detects it and passes the information on to the government server, where they collect this information and then automatically send resources out to fill these potholes. Within a few months, what do they realize? All the pothole requests, what they were collecting was all the resources were being sent to wealthier neighborhoods. It's not that the wealthier neighborhoods had more potholes, right? It's not that there was somebody fixing this, somebody is trying to game the system and put it there. It's just that what they figured out was in the poorer neighborhoods, people just didn't have smartphones, and a lot of them didn't have cars. So that information was not getting to the right place. And these kind of things, well-intended AI, could lead to a lot of societal inequality. I think the big question for our time is not whether AI is going to replace all jobs and we won't have any jobs. I think the big question for our time is whether AI would lead to more inequality, and how can we design AI so that it makes the society better rather than dividing it. And that's where a lot of my ongoing research is going on.
Well, thank you, Param. You touched a lot of interesting points, a bit of an outline of where we can go next. I'm interested on the business side and how businesses relate to AI, because this transformative technology will impact us. The speed at which it will impact us is going to be driven by how quickly it will be adopted by firms, by enterprises. In this respect, how the cost of adoptions will evolve is kind of a key aspect. So maybe I want to go back to Alexander, and you have a particular perspective, having been an entrepreneur and now working with a B2B provider of AI services. How do you see the cost for this technology changing? Is it now at the reach of all firms, or are we not there yet? Where are we at?
Yeah, I think you made the observation when we were talking that real accelerated adoption happens when the cost is low enough. Mm-hmm. And I think we're at the cusp. We're not quite there yet as far as full-blown adoption of AI in a really fast acceleration. It seems like it, but it's not. And the reason is because the cost is high, and that cost comes in terms of expertise. So it's really not even if you can afford it actually, which is hard, getting harder and harder. There's a small number of people who can really deliver the full AI capability. So it's scarcity, and then when you can find them, they're really expensive. So so that relates to the ease of use of not using AI exactly, but creating AI for your application. So automation of that is a big interest of mine. There are many parts of it that are sort of costly. It requires just a lot of smart people. So part of it is creating models or data science. Data science is one way to say it is just applied AI. Yeah. But it's all this kind of ugly business of munging data and then transforming data and so on. Still kind of an ugly mess, basically. And then the part after the sexy machine learning, training a neural net part, is also ugly as deployment. So both of those things are clunky and not well formalized and so on. So that's a big part of the cost. But all these things will go down via various forms of both education and automation. It used to be, I remember, oh my God, neural net, deep learning is a thing, and there are only like 6 people who know how to tweak deep learning models, and that's changed rapidly. Tools help that, education helps that. So, but I would say it's really the expertise that's the cost right now.
It's an interesting point. It's like AI is going to replace certain type of skills, but the cost of AI is driven by the lack of certain other skills. So the balancing of these two seems to be crucial. I want to open up to the entire panel because one of the points that emerged now was, we are all educators or have been educators, so we play a critical role in both providing those skills and making sure that if those skills become obsolete, to provide alternative skills. So I want to ask the panel what is their thought on what are, what should we be doing as educators in face of these big technological change, and what initiative do you see out there that try to tackle that?
Okay, I will go on this. So this is a very interesting question, and let me say, as director of the PNC Center for Financial Services Innovation, a lot of companies reach out and talk about like, what can we do with AI, and they are all the time asking to collaborate with CMU. And one of the things I've learned from them, hiring good graduates on who really know AI and machine learning really well is extremely hard. This is like huge scarcity. I believe like a lot of them just want to come work with us so that they can hire our graduates. And if you see like what as educator we should be doing, I believe if you were to just apply machine learning model, it's almost trivial now. There are so many packages out there. You don't even know what goes on in this package. You apply it, you get some results, and you sell it to somebody else who also doesn't understand what it is doing. He's believing AI is magic. So this is I feel like several times like where like I'm communicating with some of the industry folks, and sometimes it will come out, the person just expects that AI will deliver some magic. In the end, what AI really does at this time is, at the core, it does a lot of things, but one of the major things it is able to do, get a set of inputs, get a set of outputs, and get a very good labeling on that. This is what at the core, what AI is really well doing at it. At Tepper, what we are doing with students particularly is we have these courses in which we are actually teaching them how to build these systems itself, and not to just take it as a black box, understand it, why it works, and what would be the challenge, what are the underlying assumptions that are out there that you should be familiar with. Even if as a MBA graduate, you're not gonna go and get your hands dirty and build the systems, but if you don't understand what goes on in it, it's not gonna, anybody can fool you basically. Right? So that's where we are going. Another thing which I always tell students to do is go hang out in computer science building. A lot of students go,
soak it in.
A lot of them go hang out in this Newell Simon Hall. There are all these robots competing with each other, big screen. I had like some visiting faculty from other schools coming in. they go hang out there just to see these computers building in and just listening to other people's conversation. I always say this is eavesdropping. Don't do this, but there is a lot of value in that. So they should interact, become more interdisciplinary, reach out to School of Computer Science, School of Engineering, and so on, learn those things. Just a siloed business school is not the future.
Henny, we were chatting earlier about how, as these students swarm in to, look at your robots, do we also have like should we think about teaching students about the implication of their work? Is this something that we have a responsibility doing, since there will be so big agents of change?
Yeah, absolutely. So before we get too far, I want to remind everyone that the School of Computer Science now has an AI major for undergraduates, which started this year, it has accepted its first class this year. And part of this AI major is actually a specific class on ethics and societal impact. I think we're beginning to appreciate as a society, and some people have been saying this for a very long time, that it's critical that as computer scientists and as business people, we understand the impact of our technology going forward. We've seen it in all cases, right? We've seen it in machine learning algorithms for facial recognition that can't recognize faces of a certain race, or decision-making systems that bias decisions toward preferring certain socioeconomic classes. So we absolutely need to understand the ethical impacts of our AI, and I think that ethics goes beyond these abstract concepts of the trolley problem, right? We can think about ethics in a very philosophical way, but we can also think about ethics in an incredibly practical way. Something that I've noticed a lot of people starting to do is incorporating in their education how their particular area has ethical questions in it. So one example is we've seen recently computer vision systems, graphical systems that can replace one person with another person. So you can basically make one person seem to be speaking when they never actually spoke those things, right? You can kind of create these fake videos. That's an amazing technology in graphics. There's also a societal implication there, right? And that's something we can teach too. So I think it's critical that we do that. I think Carnegie Mellon actually does that very, very well.
I would add to that, we're lucky here. We are the only computer science department school started by a collaboration between a psychologist and a mathematician, computer scientist. And I think that set us up for success very early, because the two of them together made a statement about what the field of computer science was going to be, and it was very different from what that statement was at other universities. Here we say that the study of computer science is the study of all phenomena around the computer, including the person sitting in front of it. And today we don't necessarily sit in front of it, of course. It's not necessarily the size of a room, but we still are the ones, it's a socio-technical system. We, together with machines, create a system that works. And I think we're lucky here at Carnegie Mellon to have a Department of Human-Computer Interaction, to have the first Department of Human-Computer Interaction, to have many courses that are available to students across the school and also across the entire campus. I think that's very helpful for this kind of issue, such as algorithmic bias and so forth.
I want to stay with you, Justine. I saw something interesting, like, maybe it's my own concerns, but the ability of a computer to teach, is this something that we can reach? Is that a limit? Is the bridge too far in some sense? Is it like a tool to help us in our teaching, or it can go beyond? Can we learn from a computer?
There are so many ways to involve AI systems in the work of teaching. Today there are so many paths, and I myself and my students have been working very hard on K-12 tutors. In fact, we found that those tutors that incorporate, not surprisingly, social interaction are more effective. And that's based on looking at kids tutoring one another, teenagers. Turns out that when teenagers insult one another, they learn more math. Now,
I'll keep that in mind.
Yeah, so talk about an ethical problem. Do we build machines that insult the children that they teach? So we're struggling with that one, but in the meantime, we know that systems that can create a bond, that work as collaborators, not as jugs of knowledge that get poured into learners. We really have to eschew, we have to stay away from that very old-fashioned image of what teaching is. We are not sages on the stage who pour knowledge into our students. And that's where AI comes in, because AI promotes a kind of adaptive, personalized teaching, is capable of a kind of adaptive, personalized teaching that previous teaching systems, previous computer science approaches to education were never capable of. And that's something that started here at Carnegie Mellon, really first with Herb Simon, John Anderson, Ken Cadinger, and that ancestral lineage of people working on adaptive teaching.
Thank you. I want to move a bit from education to workforce. The moment we think about AI and other technological developments, panic is often, a feeling that society at large might have. As an economist, however, I also see that in the past, not all big technological changes meant bad news for workers. For example, when we electrified more and more businesses, what we actually saw was that the gap between the skilled and unskilled actually narrowed. So there is, we have plenty of precedents of instances where technology actually redistributed and made the curve flatter across skill levels. I want to hear your opinion on are there concerns that you have about what will be the impact of AI on the workforce, and also what are, maybe some upside, what are some opportunities that you see that AI can provide to certain type of skills and certain type of workers? Oh, no, one at a time.
Okay, so this is one topic on which I've been thinking quite a lot, because a lot of business students also ask, are we going to be replaced by robots? And if you were to believe the media, it looks like none of us will have a job. But I'm going to say here, I believe with AI, we'll have an unprecedented increase in jobs. I think AI is going to create more jobs than take away jobs. And there are multiple reasons why I think so. Right? And this is like a long discussion we have been having with a lot of colleagues on what would happen in this case. So let's say a few reasons why I think that's going to happen. One of the reasons, every time a technological change has happened, a new technology has come, we have always seen more jobs happening after that. Right? Last time the technological change happened, we saw like the demand for skilled workforce went down, but the demand for college educated folks went up. And more people started going to college. With AI, what is happening, and you guys, if you are at CMU, you have already seen this. We are getting increasing number of people who want to get more technologically savvy education. And so now with AI, the demand for regular college education, my guess is probably going to go down. But for more techie education, more what we say gritty kind of an education, that is going to go up. And we have probably the record number of acceptances all across the CMU. And this is already starting to happen. Other thing that I say is, there was a very interesting article that our Tom Mitchell and Eric Binjolson wrote about like what kind of jobs is AI going to replace, right? So any kind of routine tasks have already been replaced with the older generation of technology. Then there was these tasks which are non-routine tasks, some of which AI is already starting to replace. But those tasks form a small set of all possible tasks. You need really good amount of data for that. You need a really good problem setup with very clear inputs and outputs. You should be tolerable to some sort of errors in that process. You should also have like very short causal chain. It can't be 5 things happening which lead to this cause. If that happens, those kind of they narrow down to very small set of tasks which can be done. And remember, a job is composed of many tasks. What always happens is some component of your task, some of these tasks are going to be automated. And when they get automated, actually they make you more efficient. So the people who can work with these technologies, they are going to do much better. So that's where I think education will become more and more important, where you understand these technologies and you can work with them. So demand for those people will go. And finally, I would say really a thing that I've always wondered. We always believe 8-hour work day is a full day of job. why it's not 2 hours. I would like to work 2 hours, get the same salary. But if I can do the same job. I think the whole definition of job is going to change all across the world. If you have seen, this is already happening. Certain countries which used to have a 6-day-a-week work, now they have 5 days a week. Certain countries in Europe are trying out 4 days a week. I think this will probably go to 2 hours a day work, 3 days a week, computer doing half your job, you work with it. So we are in good times.
Param, we have the dean here. Will please, please make us do. So was it 3 hours a day, twice a week?
Yes.
Anybody wants to push back a bit on Param? Are there certain concern or aspect that you're worried about?
Well, one context that I've been looking at a lot recently is the customer service call center. So call centers make up a lot of work around the world. When you call Sears, you don't necessarily talk to somebody, you usually never talk to somebody at Sears. You don't even necessarily talk to somebody in the United States. And there's been a worry that call centers are going to be replaced by machines. Increasingly, those call center representatives are asked to deal with more and more calls simultaneously. So increasingly, it's no longer a call, it's text. And in case you haven't experienced that, the number of these centers that are using calls is going down dramatically, and the number of the centers that's using text is going up dramatically. So these call center representatives are thereby expected to work with up to 25 customers at once. That's impossible for one person, unless that person is supported by a computer. And so my students and I have been thinking through the challenge of what we call the agent whisperer. That's a computer that whispers to the customer service agent what the next thing to say is. And a computer is better at a person than keeping track of 25 simultaneous conversations. So it can maintain the topic, the cohesion of the topic across bits of conversation. But it's also, in our lab anyway, good at saying, you haven't said, I'm here to help. I'm so sorry that this is happening to you. And so we're looking at ways for this agent whisperer, both to suggest ways to keep the coherence across 25 conversations, but also to diminish the number of calls that come in, because the agent inspires trust and rapport with the customer, and that diminishes complaints. So there's another kind of collaboration.
Henny, I think also your work might be pointing in that direction, in the sense like assisting elderly, assisting the most fragile workers in the workforce. They might actually empower them to do work that otherwise they might not. Have you any thoughts about that?
Yeah, absolutely. So a lot of the goal of kind of assistive robotics is to empower people who might not be in the workforce right now to be able to join the workforce. But caregiving is actually a huge part of the US workforce. There are many, many people, either paid or unpaid, who do work around caring for other people. The benefit of robots, in my mind, in that space, is to allow people to do, as I said before, the things that people are actually very good at. I think the agent supporting rapport is really fantastic and really revolutionary. And I'm actually dealing with a simpler problem, which is how do we get agents that can just figure out what people need and take care of background tasks so that a human caretaker can come in and spend social time with someone who's living at home by themselves and doesn't necessarily have the capacity to socialize outside of the house. So that's one element. I wanted to kind of amplify what Justine is saying, that human-machine teams, right, human-robot teams or human-computer teams really give us the capacity to become better at what we do. And I think that is really, for me, the future of the workforce is building these collaborations between people and robots, not having robots that replace people wholesale, but having robots that make people's jobs better so that people can be more efficient.
Thank you. Alexander, we were talking earlier, you are slightly more pessimistic about the impact of AI on workforce. You want to share your thoughts about that?
Well, I guess I'll give you a plus and a minus.
Okay.
So on the plus side, I think similar to what Param said, it's hard to predict actually what happens when you have a new technology. You know, somehow jobs change. You get more of something, less of something else, and sort of always sort of worked out so far. So, you know, you could say that's the most likely thing. Now, I think, but implicit in that, the minus part, is that there's time to re-educate people and adapt as a society. So, at least in the United States, we're not actually very good at that, I think. So, meaning so if you've ever seen Ray Kurzweil give a talk, you know, everything that matters to us, we watch the curve of advancement in whatever technology, CPU speeds and so on. And so all technologies that are in some sense of high interest to us move exponentially. Moving exponentially means the last 20 years is not the same growth as the next 20 years. So we can't really judge by the last 20 years. It's going to go way faster. So every 5 years, it's way faster, right? So, you know, you think about AI, blockchain, quantum computing, fully homomorphic encryption. These are like massive. When these things really arrive, they change everything in some big way. And there's just more of them, and they're going faster. So, so the challenge for us is in one of the big ways we can deal with that is to accelerate the pace of re-education, reskilling.
Thank you. I'm looking at questions that are coming in from people in the audience and online, and a lot of them are about concern about the impact of AI, risk that might be generated by them. For example, one is, let's see here, is about the we touched earlier, like, well, skilling, sending people to university might be something that we have to do more, but not everybody can do it. So a question that has been submitted is, as the difference between technology haves and have not increases, how do we ensure democracy of education, training, and opportunity for the population? So there's a question about access. How do we guarantee that?
Go ahead.
So I'm beginning to work on a project in the Ivory Coast where we're thinking about, and this is work with Amy Ogan, and this is a project that she got funding for from the Jacobs Foundation, which is chocolate money. And so they're very concerned with the children of cocoa workers who themselves are often child cocoa workers. And one of the things that they're looking at, and this is something that I've looked at for the last 20 years, is what I've called, how do we design to the least common denominator? How do we ensure that everything we build is deliverable on a non-smart phone, but on a cell phone? How do we ensure that you don't need 4G bandwidth to get the programs that we build? And I think that this divide between the haves and the have-nots, it's not a natural thing. It's a choice. And it's a choice that, unfortunately, falls on us as computer scientists, as well as on economists and business people, as we think about what we're going to develop, how we develop it, and how it's marketed.
Anybody wants to add on the access to education, access to skill?
So this is again, as I said earlier, this is the biggest challenge of our time. AI coming in, people who are already better off, they're going to adopt this much more, and people who were already in this socioeconomic side, which were not as well to do, they are unlikely to adopt it. I think this is more of a policy question, what we should be thinking about. It's less of a technology question as such. So, and a lot of times I think like it's, maybe there is some sort of required education rather than free education that can be put in there. Everybody has to have this much education. I'm not sure how it can be forced upon people in a democracy, but something like that probably is one way forward. But this is going to be the big challenge. I think AI could lead to more divide if we don't think about it.
So I'm going to add to this. There is a question asking exactly, do you see a role for policymaker regulating AI? Yes. So this sounds something that it's potentially, so I'm going to ask the panel.
Let me say a few things on this. One I see is like, when we think about AI, we completely take away the human factor. Humans always adapt to any change that has ever happened, and we have survived for so many thousands of years. With AI change, we will adapt, and we are already adapting. So that would happen at some time. And we control the rate of AI, either through regulation or through market forces, that how much AI needs to be developed. So in that way, it is going to be balanced up. But if we think about in terms of regulation, where it needs to come up, a lot of times we hear this word about algorithmic bias. And some of my work is starting to look into it. And actually what we see as algorithmic bias, and what an economist or a statistician would say, bias in the data. And these become like, and this was a big challenge, because we observe from, I'm in a business school, we look at bias from more of an econometric perspective, which is really a sample selection bias or like self-selection bias that happens. And when I was looking at algorithmic bias, a lot of times we believe somehow the algorithm has learned itself to create a bias. It's a living organism which is biasing against people. And most of the time what happens is actually, I view algorithms as mirrors to the society. It is actually reflecting back the societal bias that's out there. And a lot of this, we have a lot of people at Carnegie Mellon who are working on what we call fair, accountable, and transparent AI, or machine learning, FAT-ML, what they call it. It's an interesting acronym, but it's about fair machine learning. Their focus is generally about figuring out how could I make a fair algorithm. We know society was biased, it generated the data, now my algorithm has learned that bias. How do I debias it? Right? And most of the solutions, actually all the solutions, if I'm not incorrect, are actually affirmative action. Some version of affirmative action is proposed as solutions to correct this bias, which can't be done without a regulation of being out there. But at the same time, what I would say you should be thinking about, we have a biased society here. Yeah. We are trying to make an unbiased society in this utopian world, which could take long time. We need to somehow figure out a way, how do I tweak these algorithms at this time to take us to that particular unbiased society. And this is, the algorithm is probably going to be biased to fix it. Basically, the people who are being biased against, we need to have algorithms which biases for those people to take it to that society. It's a big, I would say it's a more philosophical question, who is biased against and for. And this is an issue that I think probably rather than computer scientists, this is something which policymakers need to think about much more clearly.
And you have some thoughts.
I want to answer both questions
go ahead.
at the same time. I want to talk about the social equity question and the policy question, because I think they're related. We've been thinking a lot about AI in this conversation as a technology that gets delivered to people. But Param, as you were talking about those two stories you introduced at the beginning, I was thinking about how AI can also be a technology that analyzes society. So AI can be used itself to recognize inherent inequalities in society, right? We can analyze data streams from things like these, the cell phones with the potholes, and figure out that actually there are communities that are being underserved in different ways. As I sit here, I think of more and more, but I can think of 3 projects at Carnegie Mellon that are using AI to benefit society. One is one by Ilan Urbakash, who is in the Robotics Institute, and he's used community-wide reporting of smog and bad sense to recognize pollution. Fei Fang in the Institute for Software Research, who's also in the School of Computer Science, has looked at poaching. So it's a very environmental kind of social equity idea. So she's looked at using machine learning algorithms to predict where poachers will be hunting illegally in order to more efficiently send park rangers to those locations. And she's done this work in Africa. Gracious, and I had a third one that I forgot. So I'll remember it in a minute. But I think that there are there's a tremendous capacity for AI to reveal inequality. And then the next step, of course, is for the policymakers to use that kind of information to build better policies. And so that's why this kind of event and this kind of panel is really important, where we combine business and we combine computer science and we combine government, so that we're all speaking together to figure out how to use the technology in the most effective way to regulate and to build equality in society.
Well, thank you. We have only a couple of minutes left, and I want to throw a curveball to the panelists. Herb Simon was famously asked to make some prediction on AI, and he got, I guess, half of them right, kind of. So I want to make this thought experiment. If you come back for the 25th anniversary of INTERSECT at CMU, what would it look like? What will they be? What will AI be like at that time? Any, predictions? And we have you on tape, so we can play it back. Yeah, I shouldn't have said the tape part.
Predictions are not very good, actually. Let me say, I'm very wary of predictions. I teach a course on fintech with Brian Rutledge. Brian Rutledge predicted Bitcoin won't exist in few months, and 3 months later he was teaching a course on Bitcoin. That creates
karma.
Saying like it's so none of us is an oracle. We can't predict that far ahead. Actually, we would be there probably with some jobs working 3 hours.
Write
it down.
Again, I see a theme here. I guess I'll be replaced. There'll be like an iPad on a stick here asking you a question.
You won't be replaced. It will be your portal to this space, right? If you can't make it, you can be the iPad on a stick, but you'll be driving it at home.
The problem with prediction, I would say, is that seems to assume that destiny takes care of our future as opposed to us. We decide our future. Presumably, we're here together to decide what future we're going to bring about. Is it going to be a future where people in business and in decision-making and in other aspects of the social sciences work together with people in all the areas of computer science to bring about a future that we're in 20 years and 25 years proud of? And that's our choice. So let's choose to do it. That's my prediction, is that we choose to do that.
On that note, I want to thank our panelists for being here today. I have a couple of announcements. We have a break now. After the break, join us back for our panel on blockchain. In the meantime, I encourage you to visit the third floor, the Schwartz Center. I was there. There are some interesting demonstrations going on, and we'll be back at 3:15. So thank you.
Thank you.